Hello boys and girls, it's Mr. Giomini here to help you out with a little bit of adding and subtracting fractions with unlike denominators. Just to review from yesterday's class, some of the different steps that we can use. We want to identify and circle the denominators. We want to make sure that those denominators are unlike. If they're not, we just simply add the numerators. So once we've identified and circled the denominators, we're then going to select the larger denominator. Okay, we're going to look at the two denominators and figure out which one's larger. Next, we're going to count by the larger denominator's multiples. So for example, if the denominator was, let's say, 8, I'm going to start with 8, and I go to the next multiple of 8, which is 16, and then 24, and then 32, etc., etc. I'm then going to choose the LCM or LCD for both denominators. So once I choose that, I'm going to then figure out what did I multiply the numerator denominator by to get that LCD or LCM. I'm then going to add my numerators and then simplify if needed. Don't forget to simplify. That is a big step. Many of you seem to be struggling sometimes with simplifying, so that's something you cannot forget. So let's look at some examples. Okay, so let's take 3/4 plus, let's go with 4/6. Now, this is how it's going to be written on an assessment. I'm going to write it like this. I kind of like to look at it going vertical as opposed to horizontally. Okay. First thing I'm going to do is I'm going to identify my denominators. I'm going to circle them. I have a 6, a 4, and a 6. Now, obviously 6 is the larger one. What I'm going to now do is I'm going to put a multiplication sign here, a fraction bar, an equal sign, and another fraction bar. Or that fraction bar is also a division bar. So I'm going to count by my multiples of 6. First multiple of 6 is 6. Anything times 4 give me 6? No. Next multiple of 6 is 12. Anything times 4 going to give me 12? Yes, absolutely. So I'm going to go over here to the far end, and there becomes my common denominator, 12. I ask myself, what did I multiply 6 by to get 12? I multiplied it by 2, so I'm going to multiply both numerator and denominator by 2. 6 times 2 equals 12. For the denominator, 4 times 2 gives me 8. So I've now made 4/6 into an equivalent fraction of 8/12. What did I multiply the 4 by to get 12? I multiplied it by 3. Whatever I do to the bottom or the denominator, I must do to the numerator. 4 times 3 equals 12. 3 times 3 equals 9. Once again, 3/4 is equivalent to 9/12. I have not changed the value of this. These are still equivalent. Okay, so now I just simply add. Put my little addition sign here, my equals bar. I do not add denominators. Denominators stay the same. 9 plus 8 is 17. Now, I want to convert this improper fraction to a mixed number. 12 goes into 17 one whole time. The denominator travels with us. Okay, because it only goes in once, I just simply subtract. 17 minus 12 gives me 5. 5 and 12 have no common factors, so my answer is simplified. My final answer is 1 and 5/12. Okay, let's try another one. Let's go with 3/9 plus, how about 2/6. Now I see 6 can be reduced, 2/6 can be reduced, but I'm just going to stick with it as is. Okay, so I'm going to identify my denominators, 9 and 6. I circle them both. 9 is the larger. I'm going to put my little multiplication sign here, fraction bar, equals, so I can make them equivalent to these initial fractions. So my larger denominator is 9. I'm going to count by the multiples of 9. First multiple of 9 is 9. Nothing times 6 will give me 9. Next multiple of 9 is 18. Hey, you know what? 18 is also a multiple of 6. So I found my common denominator. It is 18. Okay, what did I multiply 9 by to get 18? I multiplied it by 2. So I multiplied 3/9 by 2/2. 9 times 2 is 18. 3 times 2 is 6. Okay. What did I multiply 6 by to give me 18? I multiplied it by 3. So I'm going to multiply 2 6 by 3/3, making I'm going to make an equivalent fraction. 6 times 3 is 18. 2 times 3 is 6. Oh, look at that. So I now add 6 plus 6 is 12. The denominator stay the same. Okay, now I have two fractions that are both, or I have a numerator and denominator that are both even numbers. Well, that should clue me in that I can reduce this at least by 2, if not by a larger factor. Well, the factors of 12 are 1, I'm going to write them down here, 1 times 12, 2 times 6, 3 times 4. What's the largest factor that goes into both 12 and 18? Well, let's see. 1 goes into everything, so I'm going to cross that out. Nothing times 12 will give me 18. 2 times 9, so that's a possibility. 6 times 3, that's a possibility for 18. We already said 6, which is larger than both 3 and 4. So I see that 2 and 6 go both into this, but the larger one, the greatest common factor, is 6. So I'm going to eliminate 2. I'm going to divide both numerator and denominator by 6 6. 12 divided by 6 is 2. 6 divided by 18, divided by 6 is 3. There it is, 2/3. Okay, let's try a subtraction one now. Let's go with 4/7 minus, let's go with 1/4. Okay, first thing I do, circle the denominators in the problem. I see that they're unlike, they're not common. I know I need to make them like and able to add them or subtract them, I apologize, correctly. I'm going to take the larger one, which is 7, count by my multiples of 7. First multiple of 7 is 7. Nothing times 4 gives me 7. Next multiple of 7 is 14. 14 is not a multiple of 4. Next multiple of 7 is 21. The only thing I can multiply by 4 to get 21 or close to 21 is 5. That is not exactly 21. Next multiple of 7 is 28. Oh, wait a minute. 4 times 7. Oh, there we go. There's my common multiple, my least common denominator, my least common multiple. So I'm going to put my multiplication sign next to both, my fraction bar, and now my equal sign because I'm making an equivalent fraction on the other side here. Okay, we just said that the common denominator for both was 28. 7 times what gives me 28? 7 times 4. So I multiply both numerator and denominator by 4 fourths. 7 times 4 is 28. 4 times 4 is 16. What did I multiply 4 by to get 28? I multiplied it by 7. So I multiply both numerator and denominator by 7 sevenths. 4 times 7 is 28. 1 times 7 is 7. Okay, key thing here. I'm going to circle the operation. It is subtraction. I know we've been getting used to adding. We need to subtract as well. 16 minus 7 is 9. Denominator stays the same. Okay, I see that 9 is odd, 28 is even. The factors of 9 are 1, 3, and 9. 1's a factor of everything. Nothing times 3 gives me 28. Nothing times 9 gives me 28. So, here's my answer in simplest terms. Okay, I hope this helps you. Enjoy. Today we'll work with the Khan Academy. If you want a little extra practice, here's a couple problems you could practice with on your own. Let's try, let's go with it. There we go. Choose another color. 4/5 plus 2/3. I'm going to write them horizontally, which will make you then transfer them to being vertical. Let's go with 1/2 minus 2/7. Let's try 7/9 plus 2/5. And those of you that want a little challenge, let's go with 1 2/3 minus, let's go with 1/2. Let's see what you can do with that. Alright, good luck, take care. If you want to answer these 4 and bring them to class tomorrow, I could take a look for you. Take care, have a great day, bye.